Alright, let's just do a quick example of assigning oxidation states and then identifying who's being oxidized, who's being reduced. So both of our reactants are just single elements. So they have an oxidation state of 0. When I move over to my products, I have a group 2 metal, so they always have a +2. Oxygen then would have to have a -2, which it normally has anyway. So magnesium is being oxidized. Oxygen is being reduced because we said that whatever's oxidized increases in oxidation state, whatever's reduced decreases in oxidation state. Yes?
Does the element that usually contains the oxygen, like, does it usually oxidize?
Yes. If there's an oxygen involved. Alright, there's one more definition type thing we need to cover. Okay, so you always have a reducing agent and an oxidizing agent. When I ask for a reducing and an oxidizing agent, this time I'm referring to the whole compound, not just one single element, okay? So the reducing agent is the reactant that reduces an element in another reactant. In other words, it contains the element that is being oxidized. So the oxidizing agent, very similar. I'm pretty sure whoever came up with oxidation states and these vocabulary words were like, let's see what we can do to confuse everyone. Alright, so if we go back to this example, this one's pretty simple because both of our reactants are just a single element anyway. So Mg, because it's being oxidized, is the reducing agent. O2 is my oxidizing agent, so since it is being reduced. So let's look at a few more examples. Can I erase this? Just erase this top part for now. Right, so if I changed this problem and asked you which is the reducing agent, which is the oxidizing agent, the way I approach these problems is I still go through, of course, I've got to calculate oxidation states for everybody. Then I look at who's being oxidized, who is being reduced. Then from there, just flip it, okay? That just makes more sense for me. I don't know why, but it does. So that's what I'll do. So, let's go through sign oxidation state. So I went through real quick and assigned the oxidation states. Do you have any questions about that part?
So for the ones like on the calcium hydroxide,
Mm-hmm.
Why doesn't it equal 0?
So it is going to equal to. Oh wait, I have this wrong. It should have been -2. So -2 plus +1 would have given me -1 overall. Since there's 2 of them, that then becomes -2, which balances the positive. I had it wrong. Okay, so now if I look for who's being oxidized, who's being reduced. Let's see. Is anything? I don't see anything being oxidized or reduced, do y'all? So this is that can happen. It's very rare that it does happen. I don't know why I included this example if it was not a redox reaction. Since nothing is being oxidized or reduced, it's not a redox reaction. All it is an acid-base reaction. This next one is oxidation reduction. So zinc increases, so it is being oxidized. Therefore, zinc is your reducing agent. Then iron goes from +2 to 0, so it's being reduced. Therefore, it's your oxidizing agent. So I have reaction practice, and I have just where you go through and assign oxidation states. I'll put them down here. Y'all can pick them up on your way out. The last thing we need to talk about with oxidation and reduction is the activities. Okay, so redox and the activity series. So I will give you the activity series on your test. You do not have to memorize that. So this activity series helps predict whether or not a reduction, oxidation, reaction will happen spontaneously. What I mean by spontaneously is that I just put these two reactants in some kind of reaction vessel and they just react. I don't have to do anything else. This is an example of using the activity series. So zinc here readily with iron, not copper. So we said here that zinc was being oxidized, iron was being reduced when we did our oxidation states. But if you look at that activity series, you'll notice that zinc is right above iron. So the most reactive metals are up at the top, least reactive are on bottom. So zinc in its solid form will be oxidized to zinc 2+, okay, with iron being reduced. The opposite iron, solid iron, being oxidized to Fe2+, will not happen. This reaction does not happen spontaneously. I know this because if I look on my activity series, iron is lower on the series. So it can't be reduced by something higher than in it. So what you do is you always look for the metal that is in the solid form, not the aqueous metal, okay? If the solid metal is higher on the activity series, that reaction will occur spontaneously. If it's lower, it will not occur spontaneously. Because they're in solution, so all of these metals are, if they are not an ion, they're a solid metal. To make them a cation, you've got to put them in some kind of solution to make them give up electrons. So let's look at two more examples real quick. Alright, so without even assigning oxidation numbers and saying this is being oxidized, this is being reduced, I just look for iron, solid iron. So I find iron, but I see that magnesium is higher up on the activity series. So no, not spontaneous. You want the solid to be higher up. So then the second one, again, I have iron as my solid. So then I look for lead. Lead is actually below it. So this reaction occurs spontaneously. There's one right here. Any questions about any of chapter 8? How about that?
Can you go over how you find oxidation states again?
Alright, so these are pretty simple, but we'll do those real quick. Then we'll do another one.
I know when it's like by itself,
It's
or it's
zero.
like with itself.
Right. So do you see the difference in these two? Like this is completely by itself, there's no charge, so it's 0. This is by itself, but it has this +2, so let's look.
So Orto's 100 is only on the 7th.
Right. I don't think we're going to get much of 8. No. 8 and 9. But I don't think we're going to get much of 9. So it'll majority be 8. Okay, let's look at the oxidation states of CR and oxygen. Alright, so there's not a rule for CR or any of the transition metals. So we know we just go straight to oxygen. It's like 95% sure that oxygen's always going to be a -2. Okay, so if oxygen is -2 and I have 7 of them, each individual oxygen is -2. But because I have 7, overall that gives me a -14. Well, I want to be left with a -2 charge when I add chromium's oxidation state to -14. So basically, I need chromium to be I need it to equal 12. So since there's 2 of them, individually it'll be 6. Kind of like a puzzle.
So you really just have to know like that little
Chart.
those ones that you gave me.
Right. Do those first, and then you can always figure out the others. 20 minutes. Alright, we'll start chapter